Hello and welcome. In this video, we will study some example of group, also some examples of non-abelian groups, and also we will see some counter examples. Okay, we start with the simple example, that is the set Q plus of positive rational numbers is a group under ordinary multiplication. Here 1 is identity and inverse of any a is 1 over a. Another example, it is very easy to satisfy or check all the axioms of group for the above set Q plus. Another example is the set R star of all non-zero real numbers is a group under ordinary multiplication. Here also 1 is identity and inverse of a is 1 over a. Okay, we move further. Here we have another example, which is the set Zn, which is actually 0, 1, up to so on n minus 1 for any n greater or equal to 1 is a group under addition modulo n. For any j greater than 0 in Zn, the inverse is n minus j, because the difference of this j and n minus j is divisible by n, so they belongs to the same class. This group is usually called the group of integers modulo n. Okay. And all the above three groups which we have studied are abelian groups. Now we move toward another example. Here we have an example of the set of all 2 cross 2 matrices. We denote it as M, and that is the set of all matrices with real entries. And this M is group under the component wise addition or matrix addition. Clearly, the matrix with all zero entries is additive identity, and for the matrix A, B, C, D, there must exist another matrix minus A, minus B, minus C, and minus D, which will play as the role of inverse of the first matrix. So M is group under ordinary addition. Now, and this is also an abelian group because addition, matrix addition is abelian, but matrix multiplication is not abelian in general. Okay, now we see a counterexample that this set M is not the group under matrix multiplication, although it is closed under matrix multiplication. Associative law also holds, and the identity also belongs to M, but inverse of every inverse does not hold, or we cannot find the inverse of every 2 cross 2 matrix. We can find only the inverse of 2 cross 2, those 2 cross 2 matrices which have non-zero determinant. So we can take a special set which is called the set of journal linear group of 2 cross 2 matrix with real entries is actually the set of all 2 cross 2 matrix with real entries and with the condition AD minus BC is not equal to 0. Means the determinant of matrices is not 0. Means we have collected all the 2 cross 2 matrices which have the non-zero determinant. It means which are invertible and their inverse can be found. So this clearly in this group the matrix 1 0 0 1 is identity, and so the inverse of every matrix with non-zero determinant holds or exists. So this group is this set is group under matrix multiplication, because if A is a matrix, capital A is a matrix, and B is another matrix belongs to general linear group of 2 cross 2 matrix over the real entries, then clearly determinant of A B is equal to determinant of A and determinant of B. So in this way, if determinant of A is not 0 and determinant of B is not 0, then determinant of AB is also non-zero. So it is clearly uh, satisfies that this group GL2R is closed under matrix multiplication, and the remaining axioms can also be clearly satisfied. Okay, the one important thing is, as I have already told you, that matrix multiplication is not abelian in general. So this general linear group is a non-abelian group under matrix multiplication. Okay. Now we can see another example. If we take the set G, which is 1, 2, up to so on, n minus 1 is a group under multiplication modulo n only if n is a prime number. So, but this is also a billion group. And another example is if we take the set of all 2 cross 2 matrices with determinant of those all matrix is equal to 1, then this set is group under matrix multiplication no matter that these A, B, C, D belongs to set of rational numbers or this A, B, C, D belong to set of real numbers or even these A, B, C, D belongs to the complex numbers. If we take this condition, then clearly the collection of all 2 cross 2 matrices is group under multiplication, but of course this is non-abelian group. So this is all in this video. I hope you have learned some examples of group, and if you found it helpful, the best way to support the channel is to like the video and to subscribe the channel. Goodbye.